Hello. This is the second video for section 2.4. The first one we talked about the operations with the functions, add, subtract, multiply, and divide. This one is a different operation. Basically, it's combining two functions into one, not with the operations of add, subtract, multiply, divide, but with a thing called a composition of functions. The words, what we're looking at here is the composition of f with g is denoted this way. I know that's kind of blurry, but it's f and it's like an open circle with g. Okay, that's not fog, it's f of g. And that's how you say it, f of g. I don't really like that notation. I like this notation much better. All right, what we're doing is taking function g, whatever that is, and plugging function g into function f. All right, so we're combining them that way. It's called a composition of functions. This stuff, as far as the domain of this thing, it's kind of a connection to make, a few connections to make, but this picture kind of helps. So, first thing you're doing is plugging in x into this system, machine, whatever it is. Okay, so this x value comes in, it goes through whatever function g does. Could be just x squared, it could be a linear function, whatever it does. The x value goes in, function g does something. It spits out a y value. Okay, that's what g of x is, that's your function notation. So whatever function g spits out, you have a y value. That is going into function f. So whatever function f does, again, linear function, square function, quadratic, whatever. Function f will do something to that y value, and then it goes through all these little coils, this flux capacitor, and then it spits out your final answer, which this little recording thing is blocking right here, f of g of x. This picture kind of helps a little bit. Let's just look at some examples to see what you're doing with these. All right, so we're given two functions, f of x and g of x. This composite function, again, this way is fine. I prefer seeing it this way. It makes a little bit more sense of what we need to do. Okay, we're going to plug function g into function f. So function f is x squared minus 1. We're going to take function g, which is 2x, and plug it into function f. So I'm just going to spell it out step by step. You don't need to do this every time, but we're plugging function g into function f. Function g of x is 2x. So we have this 2x that's being squared and then subtracting 1. This is our composite function. So it's a matter of simplifying now. 2x quantity squared is 4x squared, and we got minus 1. And that's it. All right. For the other way, the composite functions, these are not commutative, meaning you can't just switch the order and say, oh, I'm going to get the same thing. Usually, they're completely different. So g of f means we're going to take function f and plug it into function g. So we're going to take the x squared minus 1 and plug it into function g. So we got 2 times, take the x out of function g, plug in function f. And so what we have is 2 times x squared minus 1, which is 2x squared minus 2. All right, you can see that f of g and g of f are completely different, but this is the idea of how you deal with the composite functions. And that's about as difficult as it's going to get. It's just wherever you have x terms in function g, you're going to plug function f into that. Same thing up here, f of g of x. In function f, wherever there's an x value, you're plugging in function g of x. That's your composite functions. All right, have a good night. I'll see you, or a good weekend. I'll see you on Monday.